A warm welcome to all my dear friends and students. A very good morning, good afternoon, good evening to all of you. And this is the DADM, which is Data Analysis and Decision Making 1 course under VLFM MOOC series, and this is a 12-week course for 30 hours, total number of lectures being 60, and each week we have 5 lectures, each lectures for half an hour. And I am Raghunandan Sengupta from the IME department, IIT Kanpur, and we are going to start today the 27th lecture. So, we are in the 6th week. Now, if you remember, we were discussing about different types of forecasting methods, and there we considered that we can either use the exponential smoothing method or the weighted method. Then we had the exponential smoothing would be for 1 time period, 2 time period, 3 time period. By the word time period, I mean that standing today you are trying to utilize the past data. So, 1 time period would basically mean you are putting weightages of alpha 1 and alpha 2 to the predicted and the forecasted values for t minus 1, such that the weights basically add up to 1. If it is 2 time period in the past, that means you are trying to utilize the forecasted and the actual values for t minus 1 and t minus 2, and try to give weightages of alpha 1, alpha 2, alpha 3, alpha 4, such that you are able to predict the best. What is the word best? I keep repeating it, I will again repeat it, such that the weights add up to 1, and the best prediction basically you want to basically minimize some error. So, this in this case we are considering the error as the mean square errors, such that you sum the square of the errors, differentiate with respect to the parameters, put them to 0 and solve your problem. Now, I also did point out, and obviously the question would be very relevant from all of your side, is that if the parameters or the variables based on which weights based on which you are trying to calculate are themselves changing. So, that is possible. So, you basically you will have the trend, and there would be some plus minus some deviation from the trend, such that we are able to predict to the maximum possible extent. Now, when we consider the linear regression, we had the concepts of trying to predict are the same, in the sense you have the present data for all the past values for the y's, and you regress on them trying to basically predict for the future. In the case of multiple linear regression, again you have the present data, but the present data only is not y. There are basically facts of x's which are dependent variables. Some assumptions are also there. If you remember, implicitly we do not assume any assumptions for the forecasting method trend analysis, only that we consider the errors to be normally distributed. And this normality of x's, y's, covariances not existing between the x's, covariance not existing between the errors and x, those are whole set of assumptions we have assumed in the regression context. Now, in the problem formulations, very simply we consider the data being given, then we took the 3-month moving average, the 5-month moving average, then we can consider the exponential smoothing, and in the exponential smoothing we consider the weights such that we will try to basically minimize the errors, that will come later, and in the later part we will consider today is basically the trend analysis and how the trends with respect to fluctuations would be considered in order to give us the best forecast for the future. So, we are using the trend analysis, and for the example number 2, if you refer to the last set of slides in the last class. So, for period 2 based on period 1, we will first consider the A0. So, if you remember, we will consider A0 the T0, the trends and the fluctuations basically are 0, because you have to start at one point, using which we will basically try to predict. So, the values of so A1, let me highlight it. So, the value for A1 is I am putting weights of D1 has been given a d1 is basically a demand of the y value, d1 has been given a weight of alpha, and obviously if you remember, we always harp on the fact that 1 minus alpha is the other weight such that the sum of the weights is 1. So, 1 minus alpha would be the weight for the initial a naught and t naught value. So, considering 50% being the weights for alpha and 1 minus alpha. So, the value calculate for a1 would be we are considering time t period t2 because we are starting at t1 for which we are considering 0 values suffix 0. So, 0.5 into 37 plus 1 minus 0.5 which is again 0.5 into 37 plus 0. So, because we are considering a naught as 37 and the trend as 0. So, based on that we find out a1 as 37. So, a naught was 37, a1 was 37. Now, we need to find out t1. So, t1 would basically be the other parameter based on which we are trying to basically find out the actual predicted value. So, one are the weights for the past data and one is basically the weights on the trend based on which you are going to try find out in which direction the trend is moving. So, t1 would be beta, we will consider the parameters as beta. So, beta into the trend difference a1 minus a naught and plus 1 minus beta would basically again the weights on t naught. So, it could have been say for example, we could have taken t naught, t minus 1, t minus 2. So, all these weights would have come here. So, let me use a different. So, this in place of t naught we could have also considered the values of beta 1, beta 2, beta 3. So, corresponding to t minus 1, t minus 2. So, in this case it would have been not only beta and 1 minus beta, 1 minus beta. So, you would basically have a beta 1 here, a beta 2 here and a beta 3 here, considering beta 1 is the weight for difference between a and 1 minus a 0, beta 2 is basically the difference the weight we are giving to t naught and beta 3 is the weight we are trying to give to t minus 1. So, here we consider only 2 betas, so the sum is 1. Hence, the equation becomes 0.3 into the difference between a naught and a 1 which is 0 because 37 minus 37 is 0 and 1 minus 0.3 is basically 70% or 0.7 into t naught which you have already considered as 0. So, the value becomes 0. So, there initially t naught is also 0, t 1 is also 0. Based on that we find out the forecasted value for time period 2, which time period 2 would be basically the trend plus the fluctuation, it comes out to be 37 plus 0 is equal to 37. I will come to the detailed tables within few minutes. Now, for time period 3, we need to first consider the formula that alpha plus, so alpha plus d2 would be the alpha would be the weight for demand 2 actual value for the last period and 1 minus alpha. So, it is shifted because due to the indentation there is no such problem as such. So, there is no missing values or formulas inside. So, 1 minus alpha would be the weights given to a 1 plus t 1 trends and the fluctuations for time period 1. So, it is again alpha we have considered as 0.5. Why we are considering 0.5 I am going to come to that later. 50% into 40 plus 1 minus 50% into 37 plus 0. So, the value becomes 38.5. Similarly, again T 2 would basically be given weights to calculate T 2 we will give weights of beta and 1 minus beta to the values of the difference initially the difference between a naught minus a 1 and in the second case 1 minus beta would be the weight given to T 1. So, based on that once we calculate it is 30% or 0.3 into 38.5 minus 37 plus 70 into 0 it comes out to 0.25. So, now the trend basically percentage has started. Similarly, so because in the first case T 1 and T naught was 0. So, now F 3 basically is the value given by A 2 plus T 2 and if you add them up the values corresponding the fact that for the first time A 2, T 2 and all these values are changing with respect to the base value which you have started taking. So, the F 3 value becomes 38.5 plus the fluctuation which is 0 percentage sort of thing or the variance sort of thing which is 0.45 and it becomes 38.9. Now, the table which is shown here is basically goes like this. So, this is the extended calculation which we are doing for only two things which I have shown. So, on the first column on the left hand side we have the periods. So, periods are basically for this case given for January to December for 12 months, which is 1 to 12. Demands are given in the third column where I am pointing my finger starting from 37 to 54, and we do not have the demand for the 13th time period, which is the January for the next year. Based on the demand, once we find it out, we will compare our results, that will come later on. Now, we will consider the exponential smoothing, same problems we have considered for 30% and 50%. So, we write the values in the columns as I am marking 37 and the other one is basically 50%. So, this is for the 50%. Now, based on the fact we use the same formula, that means, if it is 30%, we use 30% weightages and 70% weightages for the predicted and the actual value for one time period difference, one step backwards. In the 50% alpha is equal to 0.5, we use 50% and 50%. So, it is 0.5 and 1 minus 0.5. For the one step past data, which is actual value and the predicted value for t minus 1. So, based on that we continue. So, given f1 d1 or f1 forecasted and the demand, so I am using d1 in place of y1. So, f1 d1 given, we find out f2, then we then actually get the data which is d2 and compare d2 and f2. Then given d2 and f2 we have already found out, we go into stage 3 or time period 3, we find out f3. So, that means given alpha as 0.30%. Then once the time period comes, we find we are given the value of d3, compare f3 and d3. Then we go to time period 4, calculate f4, then once the actual value d4 is given, you calculate d4 and f4. So, this way we go step by step, and the difference of the fi and di, which is d1 minus f1, that when you positive or negative, whatever it is, d2 minus f2, d3 minus f3, d4 minus f4, all this will be errors for epsilon 1, epsilon 2, epsilon 3 and so on and so forth till the 12th month, and we square these errors, sum them up, differentiate with respect to alphas, put to 0, find it out. This is what we are doing. Similarly, we do the same thing for alpha is equal to 0.5, in place of 30%, we have to use 50% and calculate the values. Now, in the trend adjusted exponential smoothing process, we need to find out the trends and the fluctuations. So, the trends and the fluctuations are technically the values based on which we find out AT and TT. So, A naught, T naught are considering as 0, based on that we proceed. So, A naught, sorry, my mistake, T naught would be given as 0 and A naught would be given the actual value, which is the predicted the actual value on time period 1, which is 37, and f1 would also be 37. So, based on, because the calculation will show that, because t naught is 0, based on that you go step by step, first find out the values of a and t, what at the particular time, utilize that values of a and t to predict basically f for the next period time. So, a1 t1 calculated, they give f2. Then we get d2, then again we try to calculate a2 t2, based on that we try to basically calculate f3, then d3 is given, then we find a3 t3, given that we find out f4, and a given f4 we generally find out from once the value comes, we find out d4 and continue in this case. Now, again the question would come, what we do, how do we minimize? So, basically utilizing that alpha and beta, you find out the difference of fi and di, find out the errors which are epsilon i's, square them up, sum them up and differentiate with respect to betas and alphas. You can do stepwise, that means to find out the trend as well as the actual values, and once given the alpha hats and beta hats, you can proceed to find out for the later time period accordingly. Now, we are also given to compute the mean square error, we need to basically compute the errors. Errors I am considering not epsilon as E suffix t. So, that would be the difference between dt and ft, the actual value and the forecasted value, where et is the error of time period t, and then we need to find out the mean square errors, which will be E1 square plus E2 square dot till the values which you have, which is En square n time period, sum them up, divide by the number of time periods, which is n. So, we need to basically find out these calculations. So, here are the charts. So, charts are basically the continuation example 2. We now basically try to find out that the errors based on the fact what are the alphas, what are the trends, and all these things. So, again the chart has the same information. In the first column the serial number is not there. So, we have omitted it. Months are given January to November, and because we are predicting for December. So, that will also be used. The demands are given, which is the second column. Now, I have basically have the errors. So, the errors would be the demand minus the actual value for the forecasted value. So, once we have, for the first case we have considered, remember we have considered the actual value is equal to demand, hence the error would be 0 here. So, the second case it will be basically F2 D2 differences, F3 D3 differences, whatever you follow the same nomenclature. If it is DI minus FI, calculate it accordingly, it can be positive, negative, whatever it is. So, once we do that, we have the third column, which is basically the errors. So, I just mark it out. Now, you square them considering the fact that okay, this is I did not mention because I have been repeating time and again. So, this is the errors based on the fact that I have used alpha as 30% or 0.3. Now, in the fourth column, once the errors are calculated, we basically find out the square of the errors and then sum them up. So, this becomes 31.31. Now, again we do the same calculation for alpha is equal to 0.5, find out the errors, then square the errors and then again sum them up. So, in the second case for the alpha is equal to 0.5, you have 22.59 as the error and 31.31 as the error for the case of alpha is equal to 0.3. So, we can definitely say using a weightages of 51 and 50% in the exponential smoothing method, we are getting a much less error, square of the errors. So, obviously, it would mean that the prediction based on which we are doing for alphas, betas, if in case they are betas, they would be the best. Obviously, you can find out some values, obviously through iteration methods, some values which will give us the best alpha. Now, in the case of the trend, we do the same calculations. We find out for the alpha is equal to 0.3 and beta is equal to 0.3. We find out the errors, which is the second last column. I should use a different colors. This also I should use a different colors. Sorry for that, but just give me a minute. So, this is the error for 0.5. Now, I go to for trend analysis, this is the error square, and the values of the error square is coming out to 18.13, which means that using the trend analysis the errors are slowly decreasing. So, obviously, there can be, in case if we want to find out, it may be possible in the exponential smoothing method which you are using, we can find out some alpha best which will give us the minimum error. Then again we can do the same thing for the trend analysis and consider there is only one value of alpha and beta we are taking. We can consider different values on alpha and beta and predict for which the errors square, sum of the square of the errors is the least, and we can proceed accordingly. Now, in the Holt-Linear method, the general equations are given by I will just first, before coming to the equation, I should basically consider what are the nomenclature. So, the nomenclature's errors are E, capital E, which is given by difference of YT and FT. FT is the forecasted, YT is basically the actual, which is basically demand, which we are considering for the examples. The forecasted values are given by FT, actual values are given by YT or DT. The smoothing value is given by L suffix T. So, how it will smooth out the fluctuations, and we also give, which you have also considered, we also give the this is the same repetition which we have done. First I discuss the problem, then I am coming. So, we consider the the trend, the weights and the smoothing constant. So, alpha is the weights we are giving and beta is the smoothing constant. The trend of the estimate of the slope of the line is given by basically beta, and the number of periods ahead based on which we will try to basically forecast is m. So, it can be 1 period, time period, 2 time period, 3 time period, so on and so forth. So, obviously, the answer remains that how do we find out alpha and beta? The logical thing being that we will try to basically find out the sum of the square of the errors, differentiate with respect to alpha and beta at stages, try to basically put to 0, which is minimizing the sum of the square of the errors, find the alpha and beta and proceed accordingly. So, again the Holt-Winter method with L1 and Y1 given as fixed, which is the 37 value which you took. We consider the difference of beta B1 as in the case because there would be a trend and the fluctuations. So, we will consider the difference of D2 and D1, which is Y2 and Y1, and alpha and beta are given arbitrarily I am considering as 0.501 and 0.072, and in m we are considering the time period as 1. It can time period 2, 3, 4 whatever it is, based on that we can do the calculation. So, the Holt-Winter method we consider January to December, the YT values are given in the second column, the LT values we will calculate based on this calculation, but the 143 which you are considering, which I will highlight now using a red. This 143 and 9 are the values which you are assuming for the starting. They can change, they can be changed based on the fact that I am basically trying to find out the minimum of the sum of the squares. So, as we proceed, the values are for the LT values are 153 till 245, and the B value basically change because they are dependent on time, they become 8.4, 8.1, 8.9. The detailed calculation which I have shown in another table for other example, they would exactly be replicated here also, there is no change. So, the concepts what I repeated, what I said are exactly the same, only I am trying to basically give different set of data to basically prove or highlight the important points. And then the FT values with the forecasted value are given in the last column. So, difference of these errors which is YT and FT would give me the errors, square them up, error square, and as the error square is found out, find the sum of the errors, minimize with respect to alpha and beta, and your problem is solved. So, the Holt-Winter method I just plot for the values of alpha and beta which I have taken. The yellow one and the red one are the lines for the actual value and the predicted value. Actual value for this set of problems is basically denoted by y, and the predicted value is basically denoted by f, suffix t basically being for the time period. So, if you see the differences, so if I consider January, so consider as a straight line. So, this difference is basically the error for middle of January, December. If we consider this, if possible, I think it should be possible. So, this is the error. So, this is the errors we are trying to basically find out and square them up and sum them up. Now, the Holt-Winter's method, in this case let me first discuss the nomenclature. So, the forecast value is there, the actual value is there, which has basically FT and YT. The trend is given by BT. So, the trend on the overall concept in which direction is moving, positive or negative. The seasonality component would also come. So, there are now two factors, seasonality and trend. So, the length of the seasonality it will be considered as S, and to what level you are going to do the prediction for the last time period was given by M, if you remember. So, now there would be three factors. One would be alpha for the weights for the actual values, point 1. Point number 2 will be the beta would be the weights for the trend, and point number 3 gamma would be the weights for the seasonality. So, what you can do technically is that find out the trend, minimize with respect to the gamma and find out gamma which is best. Once that is found out, basically then you go to the values. If it is step by step, then you basically go to the trend, find out the errors, minimize with respect to sum of the squares with respect to the betas, and find out the beta hats, and finally you find out the difference between the errors being actual value and the predicted value, square them up, sum them up, differentiate with respect to alphas, because you have already done it for the differentiation of gamma and beta. Then once you differentiate with the sum of the squares with respect to alpha, you put it to 0 and solve the problems accordingly. For the Holt-Winter's method, we consider L1 and Y1 as equal, because that is the starting that we have to consider. Then we consider there are two things. So, the trend we will consider the y2 and y1, the actual values difference between time period 1 and time period 2 are equal, such that B1 is 0. We considered a value of alpha as 0.822, beta as 0.055 and gamma value of 0. So, that means we are considering weights being of 82%, the trend component being for about 5.5% and the seasonality component being of 0%. These are the initial values. I am considering m as 1, that means based on the fact that I am going to predict on the trend front. S is also 1 intrinsically, which means the seasonality I am also considering as 1. Here we are considering seasonality as one time period, but in say for example, for different type of products like steel prices, coal prices, they would be seasonal, the seasonality which will be happening. Consider that for different type of woolen garments, you have a seasonality of 12 months. So, in that case S would be 12 in case your actual index based on the index means the what is the nomenclature based on which the time period is being calculated. If they are 1 month, in that case S is 12. In case it is basically 1 year, in that case S is 1, because that unit would basically dictate what is the value of S and M. Now, we need to basically check for normality of data. So, this is very important and we will basically consider the concept of the QQ plots. So, QQ plots would be considered in the next class, but initially let me start the discussion. So, we need to check the normality of the curves. So, what you will do in Excel sheet, basically you list the observation numbers in column 1, call it as I. So, I can be 1, 2, 3, 4 till whatever values you have, and list the data in column 2. So, in column 1 you have the index number, serial number, in column 2 you have basically the data. Now, we will sort out the data which is basically in column 2 and put it separately, and column 3 from the smallest to the highest. That means, you have ranked them. So, as you rank them, you find out the probability and basically your main essence is trying to plot it. For each ith of these n observations, calculate the corresponding tail area, which is basically the overall area of coverage for the probability perspective from minus infinity to that point. So, you are trying to basically integrate, and but in this case as integration is not possible, then sum them up because they are discrete points. They are not discrete points. I should not use the word discrete points, is basically the number of points are limited, you are basically forming a sample. So, corresponding to the fact that a value is equal to I minus 0.375, why it is, I will come to that, divided by n plus 0.25, you put calculate the values, put in column 4, use norm inverse function from Excel and basically put these values in column number 5 based on column 4. Make a copy of the sorted data and basically use and try to put in column 6, and this basically try to plot the column 5 and 6. What is to be done? I will come into details when I basically go through the concept of normality plots and the QQ plots in the next class. With this, I will end this class and have a nice day. Thank you very much for your attention.